So this is a diagram of a figure 1 is a river. Connacht's property is bound by a straight bank of river shown in figure 1 above. T is the base of a vertical tree. So if you imagine T is here, X marks the spot, or T marks the spot, so to speak, and that's it there. And C, which is this red spot here, is this part here, and that's straight across the river. So if you will, the river would look something like it's a abnormally straight banked river, but you can see that that'd be your river, something like this. Oop. Okay, and then it was the clone that Control D. That'd be your river there to there would be your river. Now it would actually have to be perpendicular, so I'm technically at the wrong angle there. It would have to make 90 degrees because C and D are along the same bank as each other, so this has to be perfection. There we go. So I'd actually get rid of that first one. And I'd be like this. Oh, here we go. And Control D. There you go. See? So that'd be C to T right there. Now, happy days that the two of them are, that's the length of your river. Okay. And we have T is the height of the tree. So T to E is the height of the tree. I'm just going to color that in green just to remind me that is your tree and that is the height of your tree. Next thing, from a point C, which is due west of the tree, the angle of elevation E from top of the tree is 60 degrees. From the point D, which is 14 meters north, the angle of elevation of to E top of the tree is 60. Oh, sorry, and then when you go 15 meters due north, the angle of elevation is 30. The land on both sides of the river is flat and at the same level. Use the triangle ECT, express TE in the form of root A CT meters. Okay, now, okay, what we're basically comparing is TE compared to CT, and we're using the triangle ECT. ECT is a right angle triangle. So I'm just going to draw ECT right here. So there's drawing dotted black here. So here's ECT. And the only thing we know about ECT is that that's 60 degrees. Now, and it wants us to use CT. So this is CT right here. And this is the height of the tree. We'll just call L for argument's sake. Okay. Now, using this function, we're expressing TE. TE is L. So it wants L in terms of CT. Okay. Or if you want, just for argument's sake, I'll just call it TE. TE. TE is the opposite. CT is the adjacent. So when we go for SOHCAHTOA, and the reason why I'm using SOHCAHTOA is it's a right angle triangle. The reason why it's a right angle triangle is that E is directly above T, and all these D, C, and T are all on level ground, even though they're opposite sides of a river. It specifies that they're all on level ground. Same level. Okay? So, therefore, what we're going to use is tan. We're going to use tan 60 equals TE divided by CT. And therefore, TE on its own is tan 60 multiplied by CT. And if you look up what tan 60 is in the old calculator, root 3. So you have root 3 CT. We cool with that? Okay. Now, show that TE may also be expressed as 225 plus CT squared over square root of 3. Now TE, what other triangle will TE be in? Because that's the explanation for TE using our triangle ECT. I need to find TE using a different triangle. Now here's what I'm thinking. See that 15? What's 15 squared? 15 squared is 225. And right there, that's 225. So I think what we're going to end up using here is we're going to use the triangle, and it specifies that it's at a right angle. We're going to use the triangle DCT. That's DCT right there. And that's 15 for D to C. And this is CT. And this here is DT. Okay, DCT. Now, I'm probably going to have to take a picture of this and drag it down with me. Just need this diagram to get this in my head. Here we go. So I'm going to grab this, I'm going to bring it downwards, like so, and we're going to try and figure out what on God's green earth is going on here. Okay, now what we're figuring out is that we have the triangle DCT and its right angles, which means I can use Pythagoras' theorem, which means I can use DT squared equals 15 squared plus CT squared. 15 squared plus CT squared is 225 plus CT squared. Okay, now that checks off this part here. See this red part here? I'm pretty happy with that because that's that part there. Now, what I'm not happy about is that I have DT squared. It doesn't want DT squared. What it wants is, it would like me to have TE instead. So it wants me to use TE. It wants me to get TE in here somehow. Now, here's what I'm thinking we're going to do. And you notice DT is not in your answer. So this part has to go. I need to substitute for DT. So I look for another triangle that has DT in it. And the triangle in question is going to be this one here. See the 30 degrees? So it's DTE and it's 30 degrees. Okay, so that's the next triangle I have to use because that's the only triangle that has DT in it that I haven't already used. So that's DTE, and it tells me that it's what's it, 30 degrees. Okay, happy days. Now I want to get TE because that's the goal of the question. I want to get TE substituted for, I want to substitute DT for TE somehow. So what I'm going to do is I'm going to use DT and TE here. One of them's the opposite and the other one's the adjacent. So I'm going to use tan 30 is TE divided by DT. Tan 30 in the calculator. Now this is always an awkward one. It's root 3 over 3, which is 0.577, and root 3 over 3 is actually exactly the same as, because root 3 is actually the same as root 3 multiplied by root 3, cancel root 3's, and it's 1 over root 3. So if you look at the decimals, 0.577, 1 over root 3 is actually the same thing. And if you look up your tables on page 14, it will also show you that. Okay, so I'm going to put that down as 1 over root 3, and that equals TE over DT. And here's what we're going to do. I'm going to get DT, it's division on the right, makes a multiplication on the left. And root 3 is division on the left and makes a multiplication on the right. And now I have DT all of a sudden. DT is sorted. Now to get DT squared, I need to square both sides. So that means multiplying root 3 TE by another root 3 TE. Okay, root 3 by root 3 is 3. TE by TE is TE to be squared. And that there gives you exactly what you're looking for. DT squared is 3TE squared. So I go back up to the top here where I had this DT squared. And I sub with 3TE squared. What I do next is I get that tree, which is multiplication on the left, and it's going to be division on the right when I bring it down. So that was multiplication on the left, it's division on the right. And see this square sign? I'm going to square root both sides, and lo and behold, I get the answer I was looking for. Okay, quite a difficult question. Part 3. Hence find CT, the distance from the base of the tree to the bank of the river at Connor's side. Give your answer correct to one decimal place. Hence find CT. This is a difficult question. Oh, now believe it or not, you could have done this question without doing part B. That's the one thing you got to realize about this sometimes, that the answer of A and B, they're sort of given to you. So basically you're asked to put this equation here is going to be equal to this equation here. The two of them are going to be equal to each other. So in effect, it's going to be root 3 CT equals, because that's TE, and the other one's also TE. So you didn't actually have to get any of this out to be able to attempt part 3. And what we're finding is the past papers are like this a lot. Okay, so I'm just going to copy and paste this over. And I think that's how we're going to do the next part, because it wants us to find CT. And lo and behold, we have CTs here, okay? Now, so I'm going to square both sides to begin. So when I square root 3 CT, I'm going to have to multiply it by itself, which is going to be another root 3 CT. And CT multiplied by CT is CT squared. Root 3 multiplied by root 3 is 3. Square root, you just get rid of the square root. And that's what I'm left with on this side. And it's root 3 on the bottom. The root 3 is within the square root, so it just comes out as 3. Okay, so if you're wondering at home, please remember the difference between squaring, for argument's sake, root 5 over 3 or root 5 divided by 3. There's a difference. If I square the first one, it's just 5 over 3. If I square the second one, it'll just be 5 over 9, because the 3 is clearly outside the square root. So just please, if you can, remember that. Okay, want to make sure your mechanics are working okay. Now, here's what we're going to do. We need to get CT on its own. So multiply 3 across, we're going to get 9 CT squared. 3 CT squared multiplied by 3 is 9 CT squared. That's 225 plus CT squared. Now, 9 CT squared take away 1 CT squared. When you bring it over the other side, it's going to be 8 CTs to be squared. Now, just got to check the old marking scheme on this. Hopefully we're going the correct way. Yeah. Yep, they're all good. Divide 225 by 8, so you're going to get CT squared equals 225 divided by 8. And then you're going to square root that. CT, get rid of the squared by doing the square root sign. And lo and behold, you should be able to get 5.3 meters when you put that into the calculator. Now, find TE, the height of the tree. Correct, give your answer to one decimal place. Okay, so if we go back to, let's keep this simple. If we go back to part A, we have that TE is root 3 CT. So TE, which is the height of the tree, equals root 3 C by T. So that's going to be root 3 multiplied by 5.3, which will give us an answer of 9.2 meters when we're done. Now, next part. The tree falls across the river and hits the bank at Connor's side at the point F. Find the maximum size of the angle FTC. Okay, so we're going to go back. I think I'm going to have to bring this over here. Okay, so we're just sort of zoning in on this diagram here. which I'm just going to copy and paste across. Okay, and we'll just click that. Okay, and we are going to put it here. Let me do that. Deal. Cut. Paste. Let's bring it down. Okay, so I always need the diagram to figure out what I'm doing. Otherwise, I'm in trouble. A lot of you are very aware. Now, let's have a look at this. Okay, we have our triangle FTC. Now, what do we know about T to C? Now, because the tree falls across and hits the bank at the point F, what we're going to assume that TF has to be the same length as TE, because at the end of the day, it's the tree hitting it's the tree that's falling over. Okay, so what we can say there is that is 9.2. Okay. I'm hoping. And CT, which we got earlier, is 5.3. And what we can say is that if we're looking for this angle here, FTC, which is going to be this angle here, and this is right angled because it's directly in line with the river. Okay, and does it say that in the description? Hits the bank at corner side F. Hits the bank. So the bank means it hits the edge of the river. So it's in line with C, which makes a 90-degree triangle, which means you're able to use SOHCAHTOA. We have adjacent and hypotenuse. So it's going to be cos x equals 5.3 over 9.2. We're going to cos inverse that. Shift cos inverse 5.3 divided by 9.2. And behold, we get 54.82 degrees, or 54.8. Now, you'll see in the marking scheme, the way they did it was slightly different. They used CT because we did a lot of rounding. And do you remember TF is equal to TE? So CT over TF is what we just did there. But that's CT over TE. This is probably why I don't think any of us would do it this way, but here we go. And what it is TE is root 3 CT. So it'd be root 3 on the bottom, CT, and that's a CT on top. The two CTs cancel to give you 1 over root 3, and instead you're going to cos inverse 1 over root 3. And fair play to anybody who does maths like that. You're going to get a great job somewhere, and some people might get 54.7 instead. Okay, I wouldn't imagine they take anything off for around an hour, but there we go. Now, next part. If the tree was equally likely to fall in any direction, find the probability that it would hit the bank at Connor's side when it falls. Give your answer as percentage correct to 1 decimal place. Oof. Okay, so I'm going to draw a diagram here to explain once again what's going on. Okay, so if you imagine that the tree I have can fall in any direction it wants. So it's going to take this diagram here again. Okay, and here's the tree. Okay, now the tree just about made it here. That was the tree's maximum length. If the tree goes any bigger than that, what I mean by any bigger than that, if the tree makes any steeper angle than that, it will fall into the water because it's basically like a circle. Okay, so you see the circle here? Anything in this angle, the tree will be, so it's going to make a green thing here, right? So if I fall in here to here, see there? All that angle, I'm in Connor's property. This angle here, I'm into the river, I'm into the river, I'm into the river. If I fall here, I'm on the same, I'm on the bank that I started off in. If I fall backwards, I'm over here. So this is like a basically a 360-degree chance, okay? This is all 100% of where you can fall. Now, I'm only allowed fall in this region here, which is actually 2 times the angle X we just got. So it's actually 2 times the angle of 57.4, or in our case, it was, sorry, 54.8. Now, out of all 360 degrees, because it could have fell anywhere in the 360 degrees. So it's going to be 2 times 54.8 multiplied with 360. Because this zone here is where the tree falls over the other side. Okay, so it's going to be 2 times 54.8 divided by 360. And lo and behold, we get an answer of 0.304 or 0.3. Okay, and if you use the answer of 54.7, you'll still get 0.3 as well. Okay, that's the end of that question. That question was quite challenging.